Okay, so we have the probability of A plus the probability of not A equals 1. All right, now I say if you subtract probability A from both sides of the equation, you have the following formula for finding probability of not A. So if we take this equation, we subtract probability of A from both sides, like so. You get the formula probability of not A, or A complement, equals 1 minus the probability of A. So it turns out this will be a sneaky way for us to calculate some difficult probabilities. Okay, so let's work a simple example first. Let's say you roll a die once. Let A be the event getting a 4. Calculate the probability of not A, or in other words, calculate the probability of A complement. So what's the probability of not getting a 4? Well, the probability of not getting a 4, well, it's 5, 6, because there are 5 ways to not get a 4. In other words, 5 ways for success out of 6 total possible outcomes. Okay? Now, we could have used our formula, though. We could say, okay, the probability of not getting a 4, it's equal to 1 minus the probability of getting a 4. So we could do 1 minus 1/6. 1 minus 1/6 is 5, 6. Get your common denominator. So 2 different ways to do the same problem. So you could take your pick on that one. All right. We'll do some more complicated examples with this later. All right. Now, let's say you're taking a test, and the first 2 questions are as follows. True or false? A pound of gold is heavier than a pound of feathers. Second question. Who first said the following quote? There are 3 kinds of lies. Lies, damned lies, and statistics. And it's multiple choice. Now, let X represent the event getting question 1 correct, and Y represent the event getting question 2 correct. Let's say you don't know the answer to either question, so you just guess on both. You're like, man, I don't know this one, I don't know this one, I'm just going to guess on both of them. I want to know, what's the probability of getting both questions correct? In other words, what's the probability of getting X correct and Y, or what's the probability of getting question 1 correct and question 2 correct? So, all right, well, a pound of gold is not heavier than a pound of feathers. They weigh the same. They're both a pound. So answer the first question is false. Answer the second question is C. Benjamin Disraeli. I guess he was a British prime minister. That's all I know about him. Mark Twain popularized this quote, but I guess Benjamin Disraeli first said it. So anyway. Okay, so I ask, well, what's the probability of getting both questions correct if you just guess? Well, we could make a tree diagram to see all possible outcomes of what could happen. So let's say you guess on the first question. You could either guess true or you could guess false. On the second question, so if you guess true on the first question, on the second question you could guess A, or you could guess B, or you could guess C. So these are 3 possibilities. You guess true on the first question, and then you guess A on the second. Or you guess true on the first question, then B on the second. Or you guess true on the first question, C on the second. Oh, okay. Well, you could guess false on the first question. And then on the second question, well, you could guess A. So guessing false, then guessing A is an outcome. False, then B is an outcome. And false, then C is a possible outcome. So there are 6 possible outcomes. Okay, there are 6 possible outcomes. One is a winning outcome, or in other words, one is a desired outcome. This one. So the probability of guessing correctly on both questions, probability of x and y, is 1 out of 6. There's one way for success out of 6 possible things that could happen. So, all right, well, let's look at this question another way. You could say the following. Half of the time, or half the time, you guess right on question 1. Now, if you guess correct on question 1, so if you guess correctly on question 1, 1/3 of those times you guess correct on question 2. So, well, look at what we're saying. Half the time you guess correct on question 1. 1/3 of those times you also guess correct on question 2. Well, so 1/3 of 1/2 of the time you guess correct on both. Well, 1/3 of 1/2 is 1/6. So the probability of guessing correct on both questions, well, it's 1/3 of 1/2. In other words, it's 1/2 times 1/3. So anytime you take a fraction of something, you always are multiplying. Like, let's say you have 8 apples. 1/2 of 8 apples is 4 apples. Or in other words, 1/2 times 8 is 4. So anytime you take a fraction of something, you're multiplying. So if you take 1/3 of 1/2, you're just multiplying. You're doing 1/3 times 1/2. And that gives you 1/6. Well, so we see in this scenario, we just figured out, oh, the probability of x and then y happening is actually equal to the probability of x happening multiplied by the probability of y happening. So we see that in certain scenarios, you can actually multiply probabilities.